The James Webb Space Telescope has sent Earth a huge admonition, and it's drawing nearer. This warning comes from the exoplanet Proxima B. With each new picture sent back, additional inquiries emerge, leaving specialists scared. Each preview from this far-off planet makes us marvel more about the secrets of the universe. Growing questions are emerging about a potentially hostile planet close to Earth. Might there be an adjoining alien planet that has unfriendly intentions? Could Proxima ever represent a danger to our very existence? The subject of alien life has captivated mankind for hundreds of years, but with current technology, like the James Webb Space Telescope, it has become a question we can explore more fully than ever before. Yet, the universe isn't making it easy to find answers. We continue to use our best tools, such as the James Webb Telescope, to catch glimpses of far-off planets and universes, hoping to find pieces of evidence that may indicate life beyond Earth. We must be practical, though. Every new picture and piece of information usually reminds us of how little we truly know. While these discoveries could be historic, they also highlight the immeasurability and intricacy of the universe, leaving us with more questions than answers. Grasping a distant planet like Proxima B could redefine our place in the universe. For scientists in astronomy, this is exciting, but for the general public, it often feels like just another piece of space news. Far off, dynamic, and sometimes overwhelming. These discoveries raise more questions than they answer, leading many to wonder how this affects life on Earth. Could Proxima truly harbor life or even intelligent life that could one day present a threat to us? Notwithstanding the colossal power of the James Webb Space Telescope, it can only show us so much. Sure, we've learned some incredible things, like the fact that we now have stunning new pictures of Proxima B, and we know that the universe is significantly larger than we ever imagined. But what comes next? The practical implications of these discoveries can feel as vast as the universe itself. Proxima B, discovered in 2013 due to its gravitational interaction with its star, was a significant scientific breakthrough for many researchers. Finding this exoplanet was like finding a new celestial neighbor. Proxima B is just slightly larger than Earth, and it orbits its star every 11.2 days, making it an intriguing subject for further investigation. From a scientific standpoint, the idea of another world so close to our own is exciting. But for most, it's hard to connect with a place that is 25 light-years away. To put that into perspective, even the fastest spacecraft humans have ever made would take tens of millennia to reach it. Imagine what it might be like to stand on Proxima B. Its star, Proxima Centauri, would appear as a dim red light in the sky, much cooler and darker than our sun. Proxima B orbits so rapidly that a year there lasts a little more than 7 days. One side of the planet constantly faces the star, meaning it's locked in perpetual daylight, while the opposite side is covered in eternal night. It sounds like something out of a science fiction novel, but the reality would be much more intense. On the bright side of Proxima B, any water would almost certainly boil into steam due to constant exposure to heat. On the dark side, however, the water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a quiet and steady neighbor like our sun. It throws out hazardous flares and intense radiation, making the surface of Proxima be a dangerous place for life as we know it. This isn't the kind of neighborhood where humans would want to set up shop. Interest in finding life beyond Earth peaked in late 2020 when scientists detected an unusual signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had an unusual frequency of 982.551 MHz, which caught everyone's attention. Such a signal could, in theory, be an indication of advanced technology, but it's too soon to draw any conclusions. More recently, the James Webb Space Telescope stirred even more excitement by suggesting that Proxima B could have water vapor in its atmosphere. Water, as we know, is a key ingredient for life, and its presence could be a game changer. To better understand how much water is present on Proxima B, researchers are using advanced techniques like spectroscopy. This method allows them to identify the gases surrounding the planet, acting like a high-tech investigative tool. By analyzing the planet's light spectrum, scientists can identify specific gases like oxygen, methane, and carbon dioxide, all of which are essential for life. Environmental modeling is another crucial approach. By using programmatic simulations of Proxima B's atmosphere, researchers can make educated guesses about its conditions. These models serve a similar purpose to how scientists use dinosaur fossils to reconstruct what dinosaurs might have looked like. However, the more we learn about Proxima B's climate, the more we are reminded of the incredible variety of life forms that exist here on Earth. Extremophiles, for example, are tiny organisms that can survive in extreme conditions, boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These resilient creatures show that life can adapt and thrive under conditions once thought impossible. Could life on Proxima B be just as adaptable? The search for life on Proxima B presents enormous challenges, not just in terms of space travel, but also in proving that life can exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere may not offer much protection. Additionally, the distances involved are so vast that new propulsion systems are needed to make space travel to Proxima be feasible. Concepts like solar sails, particle propulsion, and even more theoretical ideas like warp drives offer exciting possibilities for future exploration. However, these advances are still in their infancy and require extensive research before they can be used in real missions. While dreaming about future space travel is exciting, we need to remain realistic. Finding life on Proxima B is filled with technological and scientific hurdles. Only by advancing our technology and deepening our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This quest isn't just about satisfying curiosity. It's about pushing the limits of human achievement. Could we one day set foot on Proxima B or even make contact with life there? As we consider the long journey to Proxima Centauri, finding aliens no longer feels confined to the realm of science fiction, but rather seems like a real, tangible possibility. This thrilling shift from a distant dream to a scientific undertaking has attracted significant attention from cutting-edge organizations like Breakthrough Initiatives. These groups are dedicating massive resources to turning what would normally be an unbelievably long journey, one that could take thousands of years using today's technology, into a mission that could be completed in decades. The goal of reaching another star system within a human lifetime has started gaining momentum and confidence within the scientific community. However, these grand ambitions are quickly tempered by the stark realities of our current technological limitations. Despite significant advances in space exploration, traveling to Proxima Centauri, even at just 4.2 light-years away, still presents daunting challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey feasible in any reasonable time frame. Breakthrough Starshot, one of the most ambitious projects, envisions using powerful laser-driven sails to propel small spacecraft to speeds up to 20% of the speed of light. While this concept shows promise, it is still in the experimental stage and requires overcoming numerous technical and logistical obstacles, such as limiting damage from space debris and ensuring precise long-distance communication. While the dream of reaching Proxima Centauri and potentially discovering alien life is closer to reality than ever before, it is still grounded by the constraints of modern technology. Accelerating a spacecraft to near light speed with today's instruments feels almost impossible, like trying to solve a difficult puzzle in the dark. Even powerful projects like Starshot, which aims to send a spacecraft toward Alpha Centauri using lasers, face enormous practical challenges. The Earth's atmosphere creates disturbances for the lasers, making it difficult for space-based exploration tools to work with the precision required. One proposed solution is the use of adaptive optics, smaller lasers on satellites that constantly monitor and adjust for atmospheric disturbances. This system would help powerful ground-based lasers stay focused on spacecraft as they travel through space. However, the laser propulsion technique requires an enormous amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a limited time. Imagine setting up 100 million lasers over a vast area just to propel a small spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still take 22 years to reach the Alpha Centauri system, a time frame longer than many people's lifetimes. Yet, the challenge of reaching Alpha Centauri isn't only about overcoming technical obstacles. There are natural barriers as well. The gravity of the Sun, the presence of space debris, and the sheer vastness of the distance involved all pose critical risks. Even communicating with a spacecraft on its way to Proxima B would require sending messages through time. It would take around 4 years for a signal to reach it from Earth. Notwithstanding these overwhelming challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deep love for discovery and exploration, rather than practical necessity. Even powerful ventures like Starshot, which aims to send a spacecraft to Alpha Centauri using lasers, face many practical difficulties. However, solving these problems could revolutionize space exploration. Still, the potential risks involved, including communication delays and natural hazards, require careful planning. Nevertheless, many scientists believe that the rewards far outweigh the risks. Discovering life on Proxima B or another distant exoplanet continues to captivate minds around the world. Finding life, especially intelligent life, in a star system, only a few light years away, is a powerful notion that captures humanity's imagination and drives space exploration forward. Whether we reach Proxima or not, humanity's quest to explore the stars is just beginning. The search for extraterrestrial life has shifted from the realm of science fiction to one of active research and technological advancement. As humanity continues to explore the cosmos, one of the most tantalizing prospects is the possibility of finding life on exoplanets like Proxima B. The idea of finding a planet so close to Earth that it might harbor some form of life is both exhilarating and daunting. The sheer vastness of space means that even nearby stars like Proxima Centauri are still incredibly far away. However, the rapid progress in technology, especially in the realm of telescopes and space exploration tools, is turning what was once a far-fetched dream into a tangible goal. Astronomers are increasingly relying on a variety of advanced techniques to study planets like Proxima B. One such method is the detection of planetary atmospheres, which can reveal critical information about a planet's potential habitability. By studying the chemical composition of these atmospheres, scientists can search for signs of gases that could indicate biological processes, such as oxygen, methane, or ammonia. In the case of Proxima B, the James Webb Space Telescope is playing a crucial role in this endeavor. Its ability to capture infrared light allows it to detect faint signals from distant exoplanets, providing unprecedented details about their composition and conditions. This data could be vital for understanding whether Proxima B or other similar planets could support life. In addition to observing atmospheres, scientists are also focusing on the planet's surface conditions. The idea that Proxima B might have liquid water is particularly intriguing. Water is considered one of the essential ingredients for life as we know it, and its presence on a distant planet could be a game changer. However, the challenging environment on Proxima B, intense radiation from its parent star, and the planet's extreme day-night cycle, raises doubts about whether life could thrive there. Researchers are investigating how life might adapt to such conditions, considering that extremophiles on Earth already exist in extreme environments like deep ocean vents and boiling springs. Despite the excitement surrounding Proxima B, there are still many challenges to overcome before humanity can even consider visiting such a planet. The technological obstacles of space travel are immense. We are still far from developing propulsion systems capable of reaching the nearest star systems within a human lifetime. Concepts like fusion-powered engines or antimatter propulsion have been proposed, but these technologies are still in the experimental phase and may take decades or even centuries to develop. Moreover, the risks of interstellar travel are immense. Cosmic radiation, space debris, and the unknowns of long-term space travel pose significant dangers to both astronauts and spacecraft. Nevertheless, the potential rewards of exploring Proxima B and other exoplanets continue to inspire researchers and space agencies worldwide. Finding signs of life, especially intelligent life, on a planet so close to Earth would not only answer one of humanity's oldest questions, but could also have profound implications for our understanding of biology, evolution, and the future of our species. As we continue to push the boundaries of space exploration, the dream of making contact with extraterrestrial life grows ever more real, and the stars seem just a little closer. The potential for discovering life beyond Earth has profound implications for multiple fields of study, including biology, philosophy, and even theology. The discovery of life, or signs of life, on Proxima B would challenge our current understanding of life's origins and could provide valuable insights into how life might arise in environments very different from our own. For example, Proxima B's proximity to its star and extreme environmental conditions might force scientists to rethink the way life adapts to harsh circumstances. This could open up new avenues for research on extremophiles, organisms that live in extreme conditions on Earth, and potentially offer clues for the existence of life in similar conditions on other planets. In addition, the study of planets like Proxima B could shed light on the processes of planetary formation and the potential for habitability on exoplanets. By examining factors such as planetary composition, distance from the star, and atmospheric conditions, researchers can learn more about how planets develop over time and which conditions might be conducive to the emergence of life. This information could help scientists refine their search for habitable planets in the future, guiding them toward stars and systems that may be more likely to support life. The exploration of Proxima B and other exoplanets is also likely to push the boundaries of our technological capabilities. As we continue to develop better space exploration tools, such as more advanced telescopes, spacecraft, and propulsion systems, we unlock new possibilities for discovering and exploring distant worlds. These advancements, while focused on space exploration, often have practical applications here on Earth as well, leading to innovations in fields ranging from material science to communications technology. Looking ahead, the quest to explore Proxima B and similar exoplanets represents humanity's unyielding drive to explore the unknown. Even if direct contact with extraterrestrial life is still far in the future, the search itself promises to inspire future generations of explorers, scientists, and thinkers who will continue to push the frontiers of human knowledge and technological capability.